Many people have a problem these days. Their hands are cold. And without heat, how could they keep their hands warm? This is why in chemistry we create hand warmers. Like this little green packet right here. This little hand warmer is composed of 3 parts: a flexible plastic casing, a metal snap button, and a supersaturated solution. When the snap button is popped, a chemical reaction starts that releases heat, meaning this is an exothermic reaction, and proceeds until all of the green liquid turns into a white crystal. This process is reversed when you put the solid in boiling water, so that way we can get it to go from solid to liquid and liquid to solid. To create this hand warmer, this lab will involve you analyzing 6 substances and deciding which of these is best for this hand warmer. You will also be judging the proper hand warmer materials based on its chemical safety, its cost, and its heat generated per gram. For each substance, you will be provided the Material Safety Data Sheet, the MSDS, to determine the safety of the substances, as well as their cost, which will be on a table in your lab sheet. These 2 variables must play a role in your final decision, so take note of each. For the purposes of this lab, you will be required to analyze the heat generated by each substance in water to determine the 3rd factor in its effectiveness as a hand warmer component. To ensure this process happens, you will be learning how to design and operate a basic calorimeter. To construct it, place a styrofoam cup in a ring stand and cover the top with a square of aluminum foil. Be sure to poke a hole in the top of the foil with your glass stirring rod so that you can stir and take the temperature of the contents. No calorimeter can ensure 0 heat lost. So in your first introductory activity, you have to determine how much heat is lost to the environment, or calorimeter, for your specific calorimeter. To do so, measure 100 milliliters of deionized water in a graduated cylinder, and then pour it into the calorimeter and record its temperature. Also, prepare another 100 milliliters of water and pour it into a 250 milliliter beaker, and boil the water to about 60 to 70 degrees Celsius on a hot plate. Then, remove the aluminum foil from the calorimeter and pour in the heated water quickly. And then replace the foil and begin stirring the contents immediately. Take note of the temperature after 20 seconds of stirring and record this as your final data point. Using these values, you will be able to calculate the heat loss due to the environment for your calorimeter setup using some of the equations found in the background knowledge sheet.
Now, in the second introductory activity, you will be demoing the process of measuring the heat evolved by a solid substance in your calorimeter. For the demo, you will be using magnesium sulfate. Measure 5.0 grams of the magnesium sulfate in a weigh boat on the balance. Then, like the previous activity, pour 100 milliliters of deionized water into the calorimeter and record the temperature. Dump the magnesium sulfate from the weigh boat into the calorimeter. Replace the aluminum foil and stir the contents. Then input the thermometer. Record the highest peak in temperature produced by the calorimeter. Before conducting the lab, there are some equations you will need to be familiar with that will be utilized in the data processing section. The first is Q equals mc delta T, where Q is the heat transferred, m is the mass in grams, C is the specific heat constant of the solution, and delta T is the change in temperature. If given any 3 of the 4 variables, the remaining one can be solved for. For this lab, all values of C are assumed to be that of water, 4.81 joules per grams degree Celsius. Next, the equation Q calorimeter equals delta T times C calorimeter will calculate the correction factor of the calorimeter, where C calorimeter is obtained from C calorimeter equals Q calorimeter divided by the quantity T mixture minus T initial. To find Q calorimeter in the above equation, use the equation Q solution equals Q aqueous plus Q calorimeter and solve for Q calorimeter. Finally, to calculate the change in enthalpy, use delta H equals Q solution divided by moles of solute, using stoichiometry to find the moles of substance in your 5-gram sample and using the Q solution value from earlier.